Alright, so we want to create some topographic maps in BrainVision Analyzer that will reflect the difference between our grammatical condition, our reference condition, and some alternative conditions, in our case, grammatical violations. So the first thing we need here is the legend, the key to the markers, to our EEG markers or triggers. These are codes ranging between 0 and 255, or rather between 1 and 255, that code for certain specific purposes. They each have a certain meaning that is very important to to reflect in a document from the beginning of from the design of the study, the implementation rather. And we're going to look exactly at that. So here we have an example repository, and if we go to the documentation, we'll find the key to the markers. So we scroll down, and here we have the markers or triggers. 0 is assigned for the resetting of the port in the computer, so it isn't used for any other purpose. But then we have all those ranging between 1 to 155. You can distribute those as you see fit in as logical a way as possible. So here you can see some examples of how we went about it. And the ones we're interested in are, first of all, these three. These three are three grammatical properties of interest, so three macro conditions, three areas of research, right? And they are S1, so S is a code that you'll see next in BrainVision Analyzer. S is a code for stimulus marker. So each of these markers will be preceded in BrainVision Analyzer. They will be preceded by the S, the letter S, S1, S2, S3. And then we'll have the next set of codes, markers, which is this one, 101, 102, 103. So for each of these grammatical properties, we'll have each of these, okay? So for the grammatical property of gender agreement, we'll have three grammaticality conditions: correct or grammatical, or this is our reference. And then we'll have a violation of interest. In the case of gender agreement, it's a gender agreement violation. And then we'll have an ancillary violation, which is a control violation, an alternative one that serves, among other purposes, to distract participants from the core intention of the experiment. That's the chief purpose of these ancillary violations. And in this case, when we have gender agreement as the property of interest, then we'll have 103 corresponding to a number agreement violation, and so on. So with differential object marking, we'll have the grammatical condition, the violation, and the ancillary violation. Okay, so that's our reference. This is very important. And then we can move on to here. The first step will be to create grand averages. Grand averages encompass, summarize data across across a bunch of groups, or a bunch of rather repeated measures, let's say, right? Across a set of repeated measures. These include trials, may include participants, it depends. That's a grand average in EEG. In our case, we're going to create these plots in BrainVision Analyzer, and for this purpose, we want to make a grand average that summarizes our data across participants and across trials. So basically, that's a great grand summary, collapsing across multiple repeated measures. It's important to note that, well, for the statistical analysis, this is not the right way. This is not the recommended way for a statistical analysis, because you don't want to surrender so much information. But for the purpose of these topographic plots that we're going to create in BrainVision Analyzer, this is the right way, because we just want a topographic plot per group. We'll look at our groups next, but per group, per grammatical property, and per grammaticality condition. So we'll be looking at that, right? So per group, our groups will be 2 sets of participants. We'll make the division next based on the IDs, the numbers of the participants, which are the topmost reference node. So 10, next one will be 11, 12, 13, 14. And then, so these are our groups, and then we'll have the grammatical properties that we saw, namely markers 1, 2, and 3, and within each of those, the grammaticality conditions, namely 101, 102, and 103. All right, so let's move on to that. So we come to the area of transformations, segment analysis functions here above, result evaluation, and grand average. All right, and we see here that we have some assignments ready that had been done earlier, and we just now need to create a couple more corresponding to our other grammatical problems. So you can see here S1, which corresponds to gender agreement in our case, S101, which corresponds to the grammatical condition, the violation of interest condition, namely gender agreement violation, and the other one, right, which is number agreement violation. All right, these names are nodes that we already have in place. These nodes are over here. Yeah, these are the ones we're interested in. We can select, we have just selected this one. You can select any, usually you can select, the way is to select any raw data node here. It doesn't matter which one you select. And then this is just for reference. So the ones we're interested in here are these ones that these are just averages, not grand averages, but just averages. Namely, they are within a node, so they don't summarize across as much data as a grand average, which goes over different nodes, over different participants. Right, so yeah, you notice that these ones we have in place, and these labels are the ones we're going to use to select in our creation of the grand average. So let's get back to that. So these correspond to the ones we just saw here. And here I have prepended to each of these the name of the group, the name of the group of participants, right? So in our study, going back here, we can see some information here. So each participant was assigned certain parameters in advance, including the mini language. The order of the code was used to create is available in, yeah. So there's a CSV file that contains the assignment of these baseline parameters for each participant, and this information is available in the session materials folder on GitHub, which you can access through a link available in the OSF repository as well. Parameters per participant, Norway site, and in here you can see that one of the columns is language, which really stands for mini language, and you can see that odd numbered participants 1, 3, 7, 1, 3, 5, 7, 9, etc. Are assigned to the mean English condition, whereas even numbered participants are assigned to the mean in origin condition. All right, so knowing that, we return to BrainVision Analyzer, and what we do here is that we have selected here in the middle area, middle strip of this dialog window, we have selected the even numbers, even history files, which correspond to each participant. And therefore, here we have assigned mean in origin. We have prepended each of these with mean in origin, and then we've changed the end to grand rather than average, because this is a little more informative. In the EEG world, the grand average is a very common term, which, yeah, as I said, is slightly like it indicates usually in experimental contexts, it indicates averaging across participants, whereas simple averaging is usually performed within each participant. So these parameters are to be retained, and then our next step is to add the these kinds of assignments for the three other grammatical properties. Right, so I have added these, and we can see the assignment. So essentially, for the first grammatical property, S1, second grammatical property, S2, and last grammatical property, S3, each of these with their three grammaticality conditions. Okay, so this is all ready, and what we can do is, well, we have selected this because we have groups of participants. Otherwise, if you don't have groups of participants, you don't need to do this. You can just keep them all unselected, and by default they'll be all selected. But if you wish to select any particular ones, you just move them over this area, and then what I'll do here is to save these are mean origin S1, let's call them in this case mean origin grand averages, because it's all of them, right? It's not just for S1 but for S2 and S3. This is useful because it can be reused afterwards, so you can come here to this area and load one of these, and this will fill in the information over here, which is pretty useful. So we'll save you a few minutes. Okay, so with that we can continue, and now this will take a little. As you can see, this is scrolling down across the participants, determining, so you can see here that only the even numbers, which correspond to mean in origin in our case, are being right. And now we're going to scroll down here in the tree history tree. We're going to scroll to the bottom and click on the secondary tab, and we can see here the output from our grand averages. So we'll now create three, or rather two data comparisons. One is from our reference condition to our first violation condition, and the other is from our reference condition to our second violation condition. Specifically, we'll subtract, for each of these comparisons, we'll subtract the violation from the reference. Okay, so more specifically, we'll subtract the gender agreement violation from the grammatical gender agreement condition. That's the first data comparison we're going to make, and for the second data comparison, we'll subtract the ancillary violation, namely number agreement violation, from the grammatical condition. All right, so let's do that. So we'll first of all select our reference, which is S1 okay, namely gender agreement, property, and grammatical condition. We have selected this, and we are going to go to the feature of connectivity and statistics. Select the option data comparison. Difference is what we want. It's subtraction. Compare data sets is the option, and we'll select expand same names. Right, now here you can see that this is the raw data. Each of these are participants. If we scroll down, we can see what we want, which are the grand averages. We want to select this one, which is this is our gender agreement violation. Raw data is the one we want to select, and everything else can be left as it is. All right, this is our subtraction, our difference, and the next step is to right-click, switch view, mapping view. This is the kind of thing we want, but we'll want something a little more specific than this. We want to select a specific time window here, and we'll go for our first time window, which happens to be from 200 to 500 milliseconds. This corresponds to N2 ERP component, N2 or P2. All right, so we'll select with an interval of around 300, well, specifically rather 300 milliseconds. This is in seconds, so we want 0.3, right? And the next step is to select this little scroll horizontal bar and find where we want to be. There we are. So this is our first time window. Okay, and now we right click, save as file, select PNG, and I'll take as the base. For the base name, I'll take this one. This is session 6 here at the very bottom right corner of BrainVision Analyzer. I can see where the name of the workspace, session 6. So I'm going to select here session 6. And output it to the export window. Mean in a region, correct. S1, correct. S101 minus S1, 2, replace that. 200 to 500 milliseconds. And that is saved. And then we can select other time windows, etc. So this has been the workflow to create a topographic map reflecting the difference between two conditions. We began by creating a grand average, and then moving on to creating the topographic map. Switch the view, so right click here and you can go back to any other view. The grid view is the default one. Then you have other kinds of views. You have also this one, which is a 3D one, which is interesting, but for the purpose of creating plots for publication, it's usually the mapping view is the most interesting one in BrainVision Analyzer, because the other kinds of plots, it's a little better to create them in say in R, for instance, or in Python, where you have access to the raw data, etc. But in BrainVision Analyzer, this is a convenient interface to create these mapping plots. And I'll finish by noting the possibility of editing the size of this text, and I would recommend increasing this text, the font. So this is already larger than the default, and I achieve this by going to File, View Settings, find Mapping View, Styles, and here you can change the default, because the default is very small, much smaller. So in comparison to the map, it's very, very small. But usually I think a good reference is like the one you can see, which is 20 for the large labels and then 16